One question from the chapter matrices. We are given a matrix A, as you can see. In the first place, we have to find A inverse, and using this, we have to solve this linear equation. Now, the things that we should keep in mind while doing it. Number one, in order to find A inverse, this is what? 1 upon A determinant into adjoint A. Now, the other things we'll be using it, but let's figure out the first thing at a time. In the first part, I'm finding A determinant. So A determinant expanding along the row 1, that is 1. Eliminating this row and this column, I'll get 1 minus 3, that is 1 plus 3. Expanding along R1, as you know, we have to place a minus sign over here. So minus minus plus, this is again 1 times. Eliminating this row and column, which is 2 ones are 2, 2 plus 3, that is 5. So we need to write this is 2 plus 3 and then plus 1, eliminating this row and this column. We are getting 2 ones are 2, 2 minus 1. Right, this is 2 minus 1. So finally, we'll say that A determinant is equal to this is 4 plus 5 plus 1. That is equal to 10. So we got A determinant is equal to 10, and you know that which is not equal to, this is not equal to 0. So we'll say that it is non-singular matrix, therefore A inverse exists. Once we have calculated A determinant, the next thing we will do is finding the cofactor matrix. Now, what is the next step which I said involved is finding A inverse. For that, we have to find adjoint A. Now, I will find adjoint A using a shorter way, that is adjoint A. I'll be doing it directly. That means I'll be finding the transpose at the same time. No marks is deducted for doing in this manner. So I'll be actually expanding this along row 1, but we'll be writing along this column. We'll be expanding along row 2, and we'll be writing along this. We'll be similarly expanding along this, and we'll be writing like this. So this way we will be finding the cofactor as well as its transpose. Now let's say if I start with finding the adjoint A. So first of all, this is what? Eliminating this row and this column. This is coming as 1 minus 1 plus 3, that is 4. Expanding around R1, the next we are getting eliminating this row and column. Eliminating, this row and this column. This is 2 ones are 2, 2 plus 5, that is 3. But 5. But I'll be writing 5 over here. Expanding along R1, but writing along column 1. Now, if I eliminate this row and column, this is 2 ones are 2 minus 2 minus 1 is what? 1. Next, I'm expanding along R2. So eliminating this row, and you see, we're talking about this. So eliminating this row and this column, it is what? Minus 1 minus 1, that is minus 2. So we'll be writing minus 2 here. Next, I'm expanding. Next, eliminating this row and column, you're getting 1 minus 1. That comes out to be, this is 1 minus 1. That comes out to be 0. That's 0. Now, eliminating this row and this column, it comes out to be what? This is 1 plus 1, that is 2 here. And then now I'll be solving along R1. So eliminating this row and this column, I'm getting 3 minus 1, that is 2. Now, eliminating this row and this column, it is coming -3, -2, that is -5. Eliminating this row and this column, we are getting 1 plus 2, that is 3. Once we have obtained like this, and then we are going to change the sign of this, I call them as diagonals. That means diagonals of, now I'll be changing the sign of these elements. I'll be changing the sign of this, this, and this. That's what I'm going to do here. So changing its sign, it will become plus, this will become plus, this will become minus, and this will become minus. As I said, I'm going to change the sign of this, and I've changed the sign of this, 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 this. This way we can directly obtain the adjoint A. Now check, once we have obtained the adjoint of a matrix, now we can find A inverse. So from here, you can see how to calculate A inverse from here. How is A inverse calculated? A inverse is equal to 1 over A determinant, which we have written as 10, right? It was 10 only. We already calculated it. So this is 1 over 10 multiplied by adjoint A. And adjoint A is what? This is 4, 2, 3, minus 5, 0, 5, 1, minus 2, and 3. So we'll get this as A inverse. Now, once we have calculated A inverse, one mistake here, it was 2 here. Now, once we have calculated this part, in the next part, we have to solve this equation. The equation we have to solve is this one. We have to solve this equation. To solve this equation, first I'm going to write down. This is from here. I can say whatever is this matrix should be. This is from here, equating their coefficient. It's 1, 2, 1. And this is -1, 1, 1, and 1, -3, 1. This is what we have to get the coefficient matrix. Now, when you look into these two matrices, you'll be able to figure out that the matrix that I have just written is actually the transpose of this A. So we can write this as, this is nothing but A transpose. This is actually A transpose. Now, in order to get the value of, first we'll also obtain the matrix X, which is what? X, Y, Z, the variable matrix. And the matrix B here, you can see from figure, it's a constant one, 4, 0, and 2. Now let's arrange them. But they should know that A transpose whole inverse is same as A inverse whole transpose. So that means if I have to get the value of X, I'll say that it is X is equal to, this is X is equal to A transpose, A inverse whole transpose into B. Because you know that X is equal to A inverse B. So I'm using this idea. So we'll be writing X, which is X, Y, Z. A transpose, the transpose of this, right? It's 1 by 10. Transpose of this matrix is what? This is 4 minus 5. Writing the row column in terms of row, right? This is 2, 0, -2 and 2, 5, 3. That multiplied by matrix P, and the matrix P is 4, 0, 2. Now, in order to solve the remaining part, I'm using a single board to do it. Check, we have X, Y, Z here. This is 1 over 10. Now multiplying this row with this column, that means this multiplied by this. What we are getting here, that is 16, 0, and 2, that is, it comes out to be 18. Now next I'm multiplying this row with this column. So we'll get how much? This is 8, 0, 2, that is 4, that is 4. And finally, it is this row with this column. What we're getting here is 4 into 2 is 8, 0, 6. So 8 plus 6 is 14. So now the final part, this is X, Y, Z. Multiplying with 1 by 10 is 18 by 10 is what? 18 by 10 is 9 by 5. Or you may write 1.8, 0.4, and this is 1.4. So we'll therefore declare the value of X, Y, Z. X as 1.8, Y as 0.4, and Z as 1.4.